Understanding hierarchical dimensions. To understand hierarchical dimensions, let's look at an example. We look at this data set which has information at transaction level, where you have a given product for under a given order placed by a given customer. So this is one transaction about an order which was purchased on 5th January 2010, 6 units purchased, $660.03 of purchase. Now we have seen that when you call anything which looks like a text as dimension and anything which looks like a number as fact. Now when you talk about hierarchical dimension, the first important thing is about hierarchy. These are the type of dimensions where you have more than one dimension available. So dimension 1, dimension 2, dimension 3, and these dimensions are related to each other in the form of a hierarchy. So there will be some dimension which is a parent dimension, then another dimension will be child to that, another dimension could be child to this one. So there is a hierarchy relationship between these dimensions, and these dimensions follow what we call it as a messy rule, where this stands for mutually exclusive and this stands for cumulatively exhaustive. What do I mean? Let's go back. Let's look at this example where for order date we have the day, month and year available. So this is the day on which order was placed, month in which order was placed, and year in which order was placed. So if we look at the sales, right, and if we think about the total sales in 2010, so whatever is the sales in 2010 will be the sum total of the sales in January 2010, February 2010, so on and so forth till December 2010. So the sales of 2010, suppose it is $1,000, that will be the sum total of the sales from January 2010 to December 2010. This is called cumulatively exhaustiveness, because there cannot be a situation where the sales of 2010 will be different more than or less than the sum total of the months. Similarly, in a given month, for example in January, the sum total of the sales in January will be equal to the sales of all the days combined from 1st of January to 31st of January. Again, there cannot be a situation where the total sales of January will be more than or less than the individual sums of sales of the days. This is again what is meant by cumulatively exhaustiveness. Mutual exclusivity means that there would be a case where January sales will be overlapping with February sales, or 2010 sales will be overlapping with 2011 sales. Is it possible that there is a month which falls both in 2010 and 11? Not possible. Is there a day which falls in both January and February? Not possible. But you think, is there a week which can fall in both 2010 and 11? Possible. Week is an entity where partially few days can belong to say 2010 and few days can belong to 2011. For example, 30th and 31st December 2010 could be the first 2 days of the week, and the rest 5 days of the week fall in the next year. In this case, week does not follow mutual exclusivity, because the same week is going to fall in 2 different months. So in order to satisfy the condition of hierarchical dimensions, the individual dimensions coming together, they need to have a hierarchical relationship, and they should be following the rule of mutual exclusivity and cumulatively exhaustiveness, right? So if we go back, other than day, month and year, there are other dimensions also in this data set which can follow the messy rule, and hence these are hierarchical. For example, let's look at region, state, city. A region will have multiple states, a state will have multiple cities, a city does not fall in two states, a state does not fall in two regions, right? So this combination of region, state and city, it obeys the Massey rule, and hence they together form hierarchical dimension, with region being the top in the hierarchy, then state, then city. Similarly, you can find that you can create a product hierarchy by keeping category as the top dimension, under which we have subcategory, under which we can have, say, product or product SKU. So hope the idea of hierarchical dimension is